All right, welcome back for lesson 6, 7a, and 7b. We're going to look at constructing parallel lines in this first section. Why is geometry so important? Well, without geometry, life is pointless. You know, you need points in life. Okay. Our goal by the end of this section of the video is that you will be able to construct a line that's parallel to a given line through a point that's not on the line. All right. So construct a line through point M that is parallel to the given line. Write a parallel statement. So, what we need our compass and our ruler. If you don't have those out, get those out. We need to pick up, well, we need a line through our line, through our line, and our point. Okay, again, I'm not very happy about that point being so huge. The smaller the point is, the more accurate we can be. So our first step is to draw a line. It can go through the line at any point. We need a line. And maybe I need to extend it a little. See if I can do that. All right. Through our point. Okay. Great. So once we have a line through the line and the point, we're going to take our compass and we're going to set the point at the intersection, and we're going to make an arc. And this arc needs to intersect both of these lines that we have. We're going to take the same measurement and we're going to place it on this point M and make that same arc. Basically what we're doing is we're going to copy this angle right here. Okay, so in order to copy that angle, let me change colors. We are going to measure this distance from this point to this point. So this intersection of the arc to this intersection of the arc. All right. So when I measure that, so I need to move this so that it gets to the exact distance. All right, great. And I might want to just like mark it to confirm that I've made that correct distance. Okay, so then what I'm going to do, notice where we are. We are not on the line, we are at the arc and the arc. So we want to move up the same spot. The arc and the arc is what we're looking for up here. So I'm going to put my pin on the intersection of the arc, as close as I can. Okay, and then this is where I'm going to draw this mark. So this distance and that distance should be the same. So what we have just done is we have basically copied this angle and made a line that's parallel. I could have extended that a little further. Let's see if we can extend it further. All right. So to show that two lines are parallel, we're going to make this mark here, right? And this is R. To tell us what to name the new M, construct a line through M that is parallel to the given line. So let's call it P. Write a parallel statement. So line R is parallel to line P. Or R is parallel to P. Let's say line R is parallel to line P. All right, so the steps again. We made just a straight line through the point and the line, made an arc, made the same arc, measured the distance on the arc with the two intersections, marked off where that same distance would be, and drew a line through. This is one that really needs practice. Okay. So here I like this. So there's different ways of writing here. MN, they labeled their points. So MN is parallel to R, or you could say MN is parallel to OP, but you want to have that line segment, or the word line. All right, so we want to look at this and see, like, okay, this basically we're copying this angle, right? This is about 60 degrees, and we're copying that same 60-degree angle right there. So here, corresponding angles are congruent. So these are parallel lines cut by a transversal, and this angle right here is the same measure as this angle right here. They are called corresponding angles. How do you know that MN is parallel to R? How do we know that they're parallel? Well, they're never going to intersect, right? So if they're heading in the exact same direction, right, like they have the same slope in algebra, they're never going to intersect. So if compared to this one line that's stationary, this angle and this angle are equal, that means their slopes are the same. All right, again, construct line Q, a line through Q that is parallel to the given point. Okay, so I'm going to now go to the constructions. Oops, that's for later. All right, let's go to parallel line through a point. A parallel line through a point. And what we're doing is the angle copy method. As you'll see, there's some other methods, and if you'd like to explore those, you feel free to. But I'm just going to stick with one method. So here, draw a line, make an arc at point R, measure that distance between the intersections, mark it off, and draw that line. And they should look parallel. Put our parallel symbols. All right, so I want you to practice that. You can just draw a line and put any point above, below, and practice that skill. All right. Here we're just repeating again and again. This line right here, I already said the word, is called a transversal. It's a line that intersects two or more lines. Two lines that never intersect and lie on the same plane are called parallel lines. Okay. Cool. So you guys have this on Unit 1, Topic 1 in that packet, page 19. Here we're supposed to construct a railroad track through Hagerstown. All right, so we need to find Hagerstown that runs parallel to Washington, New York Railroad Track, WN. Okay, so here's Hagerstown, and we need it to run parallel to the track that's WN. So I'm going to draw that line. You want to draw it with a straight edge, WN. All right, and then we want it to run parallel to that line. So we need parallel through this line, through this point. Parallel to this line, through that point. All right. So we need our tools. Where are the tools? Here we go. Okay. First step, we need to start with a ruler, right? Now, it doesn't have to go through the end point. It's just its closest, so I'm just going to go through the end point. Okay. Okay, cool. So I'm going to draw a line. So this is my transversal, right? I'm going to make an arc. Let's put it in something I can see better. Maybe green. Okay, so we're going to move this so it's right where we want it. I need it to cross the line and cross this line, right? It needs to cross both here and there. Okay. Oh, I see that this is not going to be long enough, so I need to extend this line. Okay. So I need to keep that same compass setting, come up to Hagerstown, and make that same arc. Okay. I meant to do in green. That's okay. All right, we'll work this out. So I drew my transversal. I made one arc, and at the other point, a second arc. Now I'm going to measure this distance between these 2 points with my compass. I want to measure from the arc to the arc, where the arcs intersect. I'm going to move this down till I get the right distance. Maybe mark it, show that I've got it. Okay, great. And then again, I think number one mistake students make is they put their point on H and try to do something from H. But we were not at that point on the line. We were on the point above, right where the arc was. So we're going to the arc point of intersection and drawing that spot. Okay. All right, so now we have H, which should be on our line. We need to put that here, and we want to go through that intersection. Extend that a little more. All right, so that was our goal. I feel like it looks a little off. A little bit off. All right, but this is what we're looking for. Something that's parallel to WN through H. All right. So here it's asking, is it possible to construct another railroad track through Hagerstown that is also parallel to Washington, New York Railroad track WN? Oh, I thought we already did that. All right, parallel postulate. Let's check this out. Euclid's fifth postulate. Given a line and a point not on the line, there is one and only one line that contains the given point and is parallel to the given line. All right, so there's only one way. There's multiple ways you could get it, but there is only one line that is parallel to this line that goes through that point. Some of my students in the past have tried this little trick. They take their ruler and line it up, and then they just try to slide it up like that. That will not be acceptable. I need to see your constructions to show me that you've created a transversal, arc, arc, find your parallel line. Okay? So you want to practice that. All right, I think I am going to move past this a little bit. All right, so we are now on to 7A, where we are going to construct equilateral triangles and hexagons. Okay, so we have a new hospital, H, and a police department, P, are under construction. A fire station, F, will be built so that all three buildings are equidistant from each other. Determine a possible location of the fire station. Now, if you want to hit pause and work this out yourself, that would be awesome. So we want equal distance from each other, from all three. So if I put the firehouse right here, if I put the firehouse here, this would be a short distance, that would be a short distance, but these two are not that same distance. So I want the same distance between, I want this distance, and that distance to all be the same. So this would not work, in case that's what you were thinking. All right. So I think I'm going to get my compass to work on this. Let's see, where did my compass go? Let's see, that to that. Let's see what that distance is. It's about there. Okay. And I want it to be equal distance. Well, since that compass stays the same, I could go here. Whoa, that just moved. Okay, let's try that again. Okay. So anywhere in here is equidistant. Huh. Okay. And what about here? If I go here, anywhere there is equidistant. Uh-huh. What do we think? Okay, so I have the same distance. I made a circle around and a circle around. Where exactly would be equidistant from both of them? Right here and right here. So if I drew those line segments in there, I would make this distance, and this distance are all the exact same. Because this is the radius of the circle. I found the radius of the circle by measuring that distance, and this is also the radius of that circle. So we have just made an equilateral triangle. So two possible options for the fire station would be over here or over there. Now, all of those circles weren't necessary, right? As you see on the next slide, all we have is a quick little arc, 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 arc. It's a little cleaner. All right, so an equilateral triangle is a triangle with all three sides the same length. We also know that since the three angles in a triangle add to 180, if I divide that by 3, every angle in an equilateral triangle is 60 degrees. All right. So we need to construct an equilateral triangle, MTH, with side length MT. Okay. So we're going to find that side length MT. We're going to rotate it around, make an arc. Move over here, make an arc, and connect. And that should be our equilateral triangle. So this, all three of those lengths are equal. Oh, did I label it? I was supposed to label it. Okay, MTH. All right, great. So I want you to practice some of these. So we take the side length, we measure it, make an arc, move over here, make an arc. That's your third point, and you can make your equilateral triangle. All right, now, what if we extend this? We also want to build a new school. We want the new school to be equidistant from each other. Determine the possible locations of the new school. So we want it to be equidistant from the fire station and the hospital. So again, I'm going to make another equilateral triangle and get this length. Figure it out. Okay, so I'm going to rotate that, make an arc, whoops, make an arc. Technology is wonderful, but it's also frustrating sometimes. Make an arc. Okay. And I see that my arc didn't intersect. That was just the line. So I need to go back, move this here, and make another arc. Okay. So notice how my initial arc and my second arc were a little off, but this point is so huge, so it's hard to see where exactly that point is. So I'm going to encourage you to use smaller points than I used. Okay, so we can then make that. And this point right here would be a new place for a school. Now, it could be over here, but it also could be over here. So the school would be equidistant from the hospital and the fire station. And what do you notice? 1, 2, 3, 4. We're making something that looks like a hexagon. A taco truck will also be parked so that the hospital and the new school are equidistant from each other. So determine where the taco truck should go. Okay, so then we can do it one more time. Find that place where it's equidistant, and voila, the taco truck. All right, and we have just constructed a hexagon. So one way of looking at constructing a hexagon is to just continue to make equilateral triangles around one point. All right, here is method one. We're actually just going to stick with this one method as far as the video is concerned. All right, so we have our length AF. We're going to start with an equilateral triangle. Mark the center. So this is going to be the center of our hexagon. Make a circle. And then go along the edge of the circle and mark out each of the points. So each of these points we're marking is one vertex of our hexagon. It's kind of a fun one. All right. So that is our hexagon with side length AF. So let's try it. Okay, so we have this length AB. Put our point, make it the right size. Okay, so we're going to angle up. We're going to find that center. Basically, we're making an equilateral, first little equilateral triangle. All right, mark that point as the center. All right, we're going to take that. I'm not going to change the dimensions at all. I'm going to rotate it all the way around, and it should go through both of those points we just created. I'm sorry, that we started with, the endpoints. It should go through the endpoints. All right, then we're going to start at one of the endpoints, mark off little tick marks. Every time we have an intersection, we're going to go back to that intersection, mark off the next intersection, rotate around, mark off the next intersection, rotate around, mark off the next one. If we want to check it, it should match up to B. Oh, that's perfect. Okay, so I'm going to use my line segment tool instead of my ruler, but you would want to use your ruler and connect each of those intersections. And that gives us our hexagon. Lovely. All right, and there's actually just one more construction that we're going to learn and practice, and then we're going to set constructions down for, I think, the rest of this semester. So we are going to construct a square. And in constructing a square, squares are, I don't know, they were a little challenging for my students last year. The first step is to extend the line, make a perpendicular line, and then work out the square. So I think just that first extend and make a 90 degrees is where we need to focus our attention. Okay, so we're going to construct a square with side length AB. So our very first step is to extend the line. So we are going to take, oh hey, maybe I can just take this and extend it. Oh, that was so much easier. Okay, so for you, you're going to line up your ruler, and you're going to extend that line just a little extra. Now I still want my side length of my square to be AB. Okay. So what we need to do, after we've extended the line, we need to make two arcs, one on this side and one on that side. And the size doesn't really matter, but we need to intersect 2 times, once on either side with the same distance. Okay. From there, we're going to put our point on the intersection, and we're going to rotate up. You know what? This needs to be a little bit larger. So I'm going to expand it. So this one is the same all the way around. Expand it a little bit so that I can get a better picture. I'm going to make an arc here, go to this intersection, make an arc there. And what I've just done is I've since this and this are equidistant, I've made a 90-degree angle. So I can connect this point. I can connect this point B with that intersection. So I want to draw a line. And it's more than a square would be, right? So I've extended this, made two arcs, made an intersecting arc, connected that point with the intersection of the arcs. Now we can look at the square. We can say, okay, what is the size of my square? Well, AB needs to be how long? AB needs to be that long, okay? So now I'm going to rotate that around, and I want that length to be there. I want that same length also to be over here. And I also want that same length to be over here on top. Okay, so we measured here, I moved it up, moved over here, made another arc. So I've got this length AB is here, it's also there. Now I know this is a point of intersection, so that's one of my corners. So I'm going to call this C. Undo that. We're going to call this C. And then from C, I want to mark off to get that intersection so I can find my D. All right. Then I can connect those dots and make my square. So this, when I made this here, this was a 90-degree angle. Okay. All right, so squares maybe are a little more complicated, so we want to practice that. Let's check out the video that you can access. Right, so we're in our resources. Now what we just made is a square, and I believe it's all the way at the bottom. So angles, triangles, right triangles, circles, ellipses, polygons. Square is a polygon, and we are constructing a square given one side. So what that looks like is we extend the line, make an arc on either side. From each of those points. Notice how that compass got a lot bigger in between. Okay, so we get our 90-degree angle, measure AB, mark out AB. We know our C point. Then we can find our D. All right, so that is the construction of a square. So I need you guys to practice that before you come in on Thursday, so we can see how you're doing with it. All right, these are all, let's do this. Okay, construct a square WOTN with a side length of 1/2 of AB. Okay, so now I have all of AB, but I don't want this square to be the whole thing. So how do I cut this AB in half? Well, we did that construction in an earlier video where we did a perpendicular bisector, right? So we're going to bisect AB. So to bisect AB, we need to make sure we're more than halfway. Make an arc above and make an arc below. Come back here, make an arc below and make an arc above. And nowhere in there did I change the size of my compass. It should stay rigid the whole time. Okay, so what I just did is I found, oh, that's not going to work. Okay. Basically all I need is this right here. I just need to cut that line in half, right? And I lined up those points to do that bisection. Okay, so I now know half the length of AB. Now I can do my construction. Okay, so I've already extended the line, right? So our first step was to extend the line, but we've already done that. So now what we want to do is let's do different colors so we can see. Make a little arc right here. And move it around. Make a little arc right here. Sorry, that was a scribble. Okay, so we've made the two arcs on either side of this one corner. I'm going to make that larger. Go to the intersection, all the way up here, over here. I'm making too many marks here. Alright, let me erase some of this stuff. That's not part of it. That's not part of it. And this wasn't part of it. Sorry about that. Okay. So now we have a line that's perpendicular to this, right? We extended the line. I'm going to say this is my point. I can make a 90-degree angle using that intersection of pink that I just created. Clean this up a little. Okay. So I wanted it to be half. It didn't tell me whether it had to be this half or that half. So you pick wherever you want it to be. All right. But I do know that I need to have this distance right here. This distance needs to be the measure of at each side of the square. I'm going to mark off that. Come over here. Mark off that. Come over here. At that intersection, because that actually is my point, my other corner, and mark off that. Okay. So my other 2 points I've got here, we're going to call this, we're going to change this letter from B, we're going to call it W-O-T-N. So W-O, this point here is T, and this point here is N. Alright, so it's important that we know how to take a fraction of a line as well. Alright, we can make our square. Like that. Alright, so we have constructed a square. And I believe that was our last objective. Okay, for this topic. Alright, so Unit 1, Topic 1. Did a lot of constructions and introduction to Euclidean geometry. So please practice. You have extra practice in your packet, where here it asks you to do 3/4 of the length of each side. So how would you do 3/4? That's on the very last page of the packet, page 29. If you had to do 3/4, if this is the side length, our first step is cut in half. Cut in half again. Do I need to cut this in half? Maybe, maybe not. If you want to, you can. But I need 3/4. So I could say a half plus a quarter is 3/4. So technically, if I have a line segment, if I cut it in half and I cut this in half, I now have 1/2 plus a quarter. 1/2 plus 1/4 is, well, this is really 2/4 plus 1/4. So in total, it's 3/4. All right, so this length would be 3/4 the size. All right, so that is your challenge to work on that and get that completed by Thursday. All right, thank you for watching all these videos and doing all the work. You gotta practice. All right, thank you. See you Thursday.